yesterday, really. Thanks so much for that introduction. I wanted to apologize in advance. I've practiced this talk. I've given a similar talk once, and I've practiced it a few times, and it ranges between 20 minutes and 45 minutes in length. So if you see a panic look come across my face and I start skipping slides, you know what's happened. But yes, hello everyone. My name's Mike. I work at King's College London, and I build and analyze generative systems. I'm really interested in AI and creativity, and I use games to study that really. And a lot of my work has been about building systems that can be creative on their own, like Angelina and Puck, as I mentioned. Um, and On top of that, like as I've got my kind of research stuff, but on the other side, I'm also making things. So I'm making games myself. Been doing live coding lately, trying out new creative tools and techniques to try and like think more about how people like to create and why they like to create. And I've been making more and more games recently, and people often ask, like, do I use my research into game design in how I use games, in how I make games myself in my spare time? And I never really know what to tell them because the answer is sort of no. I used to tell them no, but I'm going to come back to that a little bit at the end of this talk. So today, I wanted to talk to you about. But briefly, kind of a mini existential crisis I had. I want to talk a little bit about generating game mechanics. I'm going to talk to you about a new system called Pixie that I've been working on. I'm going to talk about monkeys very briefly too, and then think about like what is we're going to return to this idea of like what is the point of generative systems research? Like why are we doing any of this? And The kind of answer I came to for myself recently while working on Pixie. I've had an interesting few years. I got a permanent position a few years ago, which is one of the reasons why people haven't heard much from me, because that's been very busy. But I'm very fortunate to be here. I've also had like my whole life's been turned upside down over the last few years, and it's also given me a chance to kind of think about what I actually want to do, like what the point of my work is. And I think especially as you get kind of less time to do that work, thinking about how you want to spend that time suddenly becomes more important, which I'm sure many of you have experienced as well. And so I was thinking, like, when I do research, but when I publish a paper, like, what is the purpose of that paper? And I came up with a few answers, and you probably have answers yourself, right? These are not necessarily answers that apply to everyone, but I think one of them is kind of you're revealing a truth of some kind, right? So we've surveyed a bunch of players, we've found this thing is generally true of players, and we're telling everyone so that designers can use that knowledge as gospel when they're designing games. It might be useful to them. It's like a new fact that they've learned. Sometimes we're developing new technology, new tools. So something that can do something that couldn't be done before, like exploring latent spaces in PCGML systems. Developing a tool that we can feed levels to, or feed some kind of input to, and then get something new out of it. So it's kind of like a new ability, a new button that we can press, something that we can use to do something that we couldn't do before, maybe. Um, and then I got thinking about how those two things often, I mean, so I wrote a paper a few years ago about what our motivations are as games researchers. And I think these two are things that I put in papers quite often, but it didn't really feel like it was cutting it. It didn't really feel like it was like actually why I did this stuff. So it kind of got me thinking for a while. And one of the other reasons it got me thinking is that the purpose of creative tools has kind of changed a lot in the last few years. And there's been a lot of strange messaging about it. So one of the things I was reminded of when I was writing this talk is this ad campaign that Meta ran last year, where they got this director to sort of talk about why AI video generation was a good idea. And he went back to some of his very earliest home videos, like his films that he made when he was a teenager, and he used AI to edit them. It was a very strange ad that didn't really work because it kind of made the videos look worse. But at the end, he talks about like, oh, the thing I like about this tool is that Anish, that's him, as a kid, would still have had to do these other things. Still would have had to have written a story and planned shots. He would have just used the AI for some of this stuff. And it's kind of like, well, why are you drawing the line there? Like, why wouldn't you use the AI to write the story as well? Like, why would you get anyone to act? Like, it's lots of these lines that are being drawn about what bits of creativity seem to be um, exposed to AI and which ones aren't is very strange right now. Lots of the legal stuff's very strange right now. Like, we sort of know that AI can do this stuff, but we don't really know where it should sit in our lives. And so I was thinking about that as well. Like, where should this stuff sit in my life and the stuff that I do? Like, what role does that play? Like, why don't I use this? People ask me all the time, like, whether I use my own research in making games, and I don't. And it kind of got me thinking why. So for about 5 years now, I've been working on a system called Puck. For reasons already mentioned, I haven't been working on it much recently. I've got one like project on the back burner, but in sort of the spare time between teaching and supervision and all this other stuff, I've also been working on a new system called Pixie that I wanted to talk to you about today. And the two systems are called Puck and Pixie because they're both kind of fairy tale spirits that you had to be nice to in order for them to help you, which I like because that is definitely how it feels with my AI systems often. Um, and so today I'm going to kind of briefly talk to you about Pixie, but I'm going to focus on what it was like to actually build and use it. And then I'm going to briefly talk to you about what that made me reflect on at the end. So when we want to procedurally generate things, there's a few kind of paradigms we can use. One is what we call generate and test, which I'm sure you'll be familiar with. So we've got this process, we make this stuff, the stuff might be broken. So we have this test phase where we filter it out and we're left with things that meet our criteria. This isn't used much by game developers because this test phase is quite dangerous. And in general, if you have a test phase, the test is normally not foolproof. And you could also be testing forever. You know, you might not get the content you want in the time required. So in general, it's not a technique that's used by a lot of game developers. More often, they use something that we call constructive generation, where we have a process which is unpredictable, it is stochastic, but we know that it's going to produce something usable at the end. So the example I give is making paper snowflakes, which I actually don't know how common this is outside of England. But you know, you fold a piece of paper up, you make some cuts to it, and then you unfold it, and it makes this nice pattern. And it doesn't really matter how you cut it, you will end up with a nice pattern at the end. So this constructive process is guaranteed to produce something that we like and that has the properties that we need. And then finally, more recently, we have PCG via machine learning, where we've got a bunch of stuff that we already know has some desirable property, or maybe it expresses a space in which there are desirable properties. And we're going to train a system to recognize those and hopefully produce something that has those similar properties at the end. So, Pixie's a system for generating game mechanics. I mean, game mechanics is maybe a very broad term, but we can think of it as little snippets of code that do something within a game. And so when I came to thinking about this problem for PCG, one of the problems is that we can't really use a constructive approach. One of the reasons is that because we're making code that's designed to be executed and that can change how the game is played, we can't guess how that will affect the game without actually looking at the game and playing it and testing it. Now, there are some kind of ways around this. So you could design a game like Mosalina. Mosalina doesn't have generated game mechanics, but it also really doesn't care whether you can solve a level or not. So it will give you a bunch of random mechanics, randomly selected from a pool, and a randomly designed level. And it will be like, well, look, if you can't solve it, just skip to the next one, basically, which I think is really interesting. It's a really interesting design. It's an example of where constructive mechanic generation could work because the game design is there to support it. But in general, we don't want to take that approach. And then maybe others would disagree with me, but I think PCG via ML often doesn't work for this specific kind of mechanic generation. And that's for a number of reasons. One is that ChatGPT or large language models in general, we can't like I when I think about building systems like this, I'm not thinking about that kind of system, partly because I want to know that this is a system that we have kind of complete control over. But also, even when examples where we have, so this is a great paper about using ChatGPT as a co-creative game designer. So in general, we find that it's sort of difficult for them to fully understand the implications of a change. So again, as we were talking, kind of like the constructivist approach, an LLM isn't executing this code, it's not testing the code, it's inferring what might happen if you put this code in your system. And so sometimes that's fine, but a lot of the time it's not going to be. And I think there's other reasons which we won't get into here about sort of the restrictions on how far ChatGPT can innovate for a very specific game design. So this sort of leads us to back to generate and test. And this is actually something I've been looking at for a long time. So if you're familiar with my work, you know that over a decade ago, somehow, I worked on a system called Mechanic Miner. And this used generate and test to generate game mechanics. And what we found is that like these two parts are pretty hard, the generate and the test part. And this part is extremely hard. So actually evaluating a game mechanic to see how good it is or whether it fulfills something is really, really tricky. And in Mechanic Miner, I kind of took a shortcut. I sort of like munched the problem up a bit and found a way to sort of test not for goodness, but for whether something changed in the game. So what we did was we generated a game mechanic. We gave the auto player a problem that couldn't be solved without the mechanic. And if it could solve the problem with the mechanic, then we said, well, this is an interesting thing. Like something has changed in the game. We don't know whether it's fun or whether it's good, but we know that something has changed. So this was cool. Mechanic Miner was a really, really fun project. Maybe one of my favorite projects from like my PhD. We invented things like a button that flips gravity when you press it. So it generated some code that inverted gravity, and it found that it was able to solve this puzzle as a result. It also invented game mechanics that kind of solved the problem, but in a way that wasn't very useful. So it generated a teleportation mechanic that modified the player's coordinates, which does solve the problem. But players don't know they have coordinates when they're playing a game. Like when you're playing Mario, you don't think about what your coordinate is in the world system. And so some mechanics, there was a disconnect between what the player understands and what Mechanic Miner understands. Anyway, I really like this project, but there's kind of a problem with it. Ideally, and this is going back to kind of what's the point, ideally we want to be able to use these things in real games. This is a game called Disc Room, which you'll be seeing a little bit of in a second. And kind of the question we're left with is Mechanic Miner actually usable in other games? And the answer is no. And the reason it's not is for various reasons. Like it's a very artificial setup. It's one I had complete control over. I was able to design this auto player that brute forced like all button combinations basically. It wouldn't transfer to a different game or even a different game engine. It was very much a research project. It wasn't designed to be used by other people. So fast forward 10 years, and I decided like I was just haunted by the fact that I'd never worked more on that project because I really liked it. So I sat down and started thinking like, what would it take to take Mechanic Miner and make it usable by other people? And basically, there are kind of four issues. One is that we're generating code for a code base that we've not seen. So we want to avoid doing things that we shouldn't be doing to it. We also don't know when we generate code, like where should this code go? So this is a very underrated problem, which things like Copilot were able to solve, which is that you need to be able to tell the system where you want this code to be generated, where you want it to be output. In Mechanic Miner, there was only one place. It was always generating code for the same place, which was pressing a button on a controller. We need to be able to test the mechanic. So if we've never seen a game before, like Disc Room, if I'm giving it to a game developer, I don't know what their game is. How are we going to test it? And finally, we need to know what outcome we're looking for. So how do we evaluate the code that's been generated at the other end? Again, last time we just evaluated for functionality, like did it solve this problem that couldn't be solved? But we don't know what a game developer might want to use it for. So we don't need to solve these problems per se, but we need to be able to design a tool where these are flexible. These are things that the user can easily adapt to their game, to their scenario. Um, and there's kind of a few other requirements that I wanted as well. So I wanted it so that if you didn't want to use Pixie, you didn't need to worry about it. Like once you integrated it with your game, you could just use your game normally and develop it, and Pixie would not get in the way. Pixie would only do stuff if you were asking it to do something. Wanted it to be able to be customizable without writing code, which technically I don't succeed in, but you'll see that we've tried to make it as simple as possible to adjust it. And I also wanted to give it lots of different ways to control and focus it. So with Mechanic Miner, I was basically just writing the whole thing myself. It was a system that only I understood. But what I want to do with Pixie was to give game designers lots of ways to control the focus of what Pixie's trying to do. Like what code is it trying to generate? What's it trying to aim for? And I wanted them to be able to bring their knowledge about the game they're making and give that to Pixie as sort of a way to help it, to give it extra knowledge. So one of the games, I think I'll skip over this very, very lovely video because I'm going to explain how this game works in a bit anyway. But one of the games that I use as a test case is Disc Room, which we're going to see a little bit of in a bit. Basically, you run around these rooms avoiding discs for as long as possible. And the key thing about Discrim is that it has a lot of different disks that do different things. So some of them move at different speeds, some of them spawn other disks, some of them have strange shapes or movement patterns, or they lock onto you and try to chase you. And so as one of the example cases that I'm going to walk you through, I wanted to get Pixie to invent a new type of disk for this game. So a disk that would have a new property that would change the way the game was played somehow. So the first thing we want to do is we want to show Pixie which bits of our code are you allowed to touch. So with Mechanic Miner, there were no restrictions. I actually discovered while making Mechanic Miner that if you use reflection, which is what we use to sort of analyze the game code, you can modify private fields when you shouldn't have permission to. Like reflection is way too powerful. So we wanted a way to really control what Pixie can and can't do. So we use C# annotations here. So you annotate fields and methods, and by annotating them, you're telling Pixie you're allowed to generate code that changes this field or that calls this method. Um, and in terms of like adding levers, I've also added annotations that let players express some knowledge. So, for example, we might not want to Pixie to waste time making the speed of a character negative or the speed of a character too high. And so we can say, look, don't set this value to anything, outside of this range. That might be something which is sort of a hard rule, or it might be something that the designer is exploring. They might want to force Pixie to do something to see what happens. But the idea of these annotations is that it's a very lightweight way, even if you're not a programmer, it's a very lightweight way to sort of annotate parts of the code and say, yes, this is safe to change, or this I want you to investigate changing and using these fields in the code that you generate. The second step is to figure out where we want our code to fire. So the way that this works is we tell Pixie, I need you to generate code which has, I need you to generate some methods that have these names, and they take these arguments, and then we can call those methods wherever we want using this callback system. So what this is mimicking is it's replicating as if Pixie had written code that was in at this location in the game. So you can see in this example here, I've inserted the callback in the onPlayerDeath method. So if we wanted to ship the game with Pixie's generated code, we would kind of cut and paste it and put it where this callback is. But by using callbacks, this allows Pixie to sort of swap in and out different generated code segments, so that it can like try different types, try different generated mechanics without having to modify the game code files. And this is nice because we can also sort of give it additional information. So here I've passed it the player object, which might be useful to it. It's local information that it might use to generate in the code that it generates. Okay, now we're getting a little bit trickier. So next is we need to design a test scenario for Pixie. So some games it's very straightforward. So for Discrim, it is literally just Discrim. So this is the jam version of Discrim. It looks a little bit uglier than the finished game, but this is the test scenario. It is just playing the game. For other games, it might be more focused. It might be just a combat scenario in a JRPG, for example, or it might just be a particular puzzle in a game with lots of different puzzles. So this is something where the designer that's using Pixie is going to create like a little test environment that's smaller than average, and it can be kind of as small or as large as they want. But the more focused it is, the better Pixie's going to be able to iterate on a problem. But for Discrim, this is nice and easy. And then it's getting trickier still. Now we need the sandbox to like autoplay itself. So this is not something that game developers normally have to do. It's something AI researchers do all the time, writing a player to play a game. There are kind of workarounds to this so that game developers don't have to write an autoplayer. But for lots of games, it's not too difficult. And we can make this sandbox very short. It can be like 5 seconds of gameplay if we want to. So our player only has to make intelligent decisions for a very short amount of time. So for Discrim, we did something very simple. Basically, we just avoid disks. Disks that are nearer to us, we avoid harder than disks that are further away. And then we need to decide what we're looking for. So this is dependent on the game. Are we looking for how well the player's playing? Are we looking for some sort of change to the game world or something like that? So with that in mind, I'll skip over the breakout examples and I'll show you some of the Discrim examples. So with Discrum, with all of the examples we've used with Pixie, actually, we used open source games that I hadn't written. And that was really important because we wanted to make sure that we weren't using game code that we had prior knowledge of. So this is an open source version made by Mads Johansson based on a Jam version by the original developers. And we've added these red disks to the game, and every time a disk bounces off a wall, Pixie will fire some code. And we also generate a bit of extra code that Pixie can fire at the very start of the game as well. So the first thing that we asked Pixie to do was to generate a level that a really good player can survive and a worse player can't. And the way we simulated this is that we gave the worst player bad reaction times. This is the solution that Pixie came up with, or rather, this was the highest fitness solution by the end of it. So what you'll notice is it's a little bit subtle at first, but every time these red disks bounce, they actually get 10% bigger. So over time, the red disks occupy a lot more of the screen space and they're a lot harder to dodge. One of the interesting things about this solution is it feels like a Discrum mechanic. It's actually not in Discrum, but it feels like, to me at least, something that Discrum would have had in it. So I really like this solution. So then I got a bit cleverer with it, and I said, okay, can you make a level where you maximize the amount of movement that a player has to do? So basically, I split the level into a 5x5 grid. Every time a player steps on one of these grid tiles, we record it. And then I said to Pixie, okay, I want your score is the number of tiles that the player has stepped on by the end. This is the solution it comes up with. So in this instance, we're not using the red disks. Sorry, we are using the red disks, but the thing that we need to pay attention to are the purple disks, which are something Pixie has generated to instantiate into the game. So every time the red disk hits the wall, it spawns like 3 or 4 purple disks, I think. But the purple discs are very slow, which means they're very easy for the good player to dodge. So the upshot of this is that there's a lot of discs, but they're not very dangerous, and it's shepherding the player around the room. So in practice, this is maybe not a mechanic you could add to Discrum because it's really hard, but it actually does fulfill the brief. So, this is enough for a game designer to maybe think, oh, okay, yeah, there's something here. Like maybe we can take this and tweak it. Maybe we don't spawn 4 discs, maybe we just spawn 1. But it has absolutely like found this interesting solution to force the player to move around the room. You can also sort of look for all sorts of stuff. So once I accidentally asked it to make the player die in the quickest amount of time possible, I didn't mean to express the objective function in this way. And Pixie's like, yeah, I've got a solution for that. It's called spawning a million disks. So, it can come up with all sorts of fun solutions. And I've generally had a lot of fun working on it. So one final example. This is actually one of the very first examples that Pixie came up with. I was building a match 3 clone, which this is when I was developing Pixie, so this was to test it, but I use it in these talk examples because it's an interesting thing. And in the code, I represented the gem color as a number, which is not necessarily how you had to represent it, right? You could represent it as a list of objects or an enum. There's so many different ways you could represent it, but I had represented it as a number. And so I said to Pixie, generate a new thing that happens when you swap 2 gems. Like maybe, I don't know what you want to do, but like do something different. So what it came up with was something really interesting. I have now changed the representation to make it clearer what's happening. When you swipe a tile into another tile, it subtracts the numeric value of the tile from the tile you're swiping into. And what this does is it turns match 3 into a maths game. Because now you're having to figure out how to get lines of 3 in a row by doing simple arithmetic. And this was such an odd like invention. And one of the things that bugs me about this is that it did this by chance, essentially. Like the evolutionary system was not in place yet. So Pixie was able to recognize that this scored very highly on the metrics we'd given it. But it actually wasn't part of the iterative process. It wasn't evolving this. It wasn't like doing any search. And so I think this is a really interesting example of like which one of us gets the credit for this. Like I didn't really come up with this idea. If I claimed this idea as my own, I'd feel quite disingenuous. But also if I told you that Pixie invented this, that wasn't really true either. So it was kind of serendipitous. It was kind of serendipitous result of both of us working together, kind of, or at the very least a result of me working on this system. And this comes back to kind of the secret third thing that I mentioned at the beginning. So There's this joke about like if you have an infinite number of monkeys and an infinite number of typewriters, they'll eventually write Hamlet. And in The Simpsons, there's this moment where Mr. Burns like comes to a bunch of monkeys that are chained to typewriters, and they've almost written Hamlet. And he gets really angry that they didn't quite get there. And the joke, one of the jokes in this scene is that he could have just edited it. Like he knew that they were close to Hamlet, and he could have just made a small change. Um, so AI is often described in this way as like monkeys on typewriters. And the thing with that is that like they really benefit from an editor, right? They benefit from someone working with them. And in Pixie's case, the process of editing and working with Pixie is really interesting. And as I was building Pixie, I was realizing how interesting it was. Choosing which fields to label, thinking about how I wanted to build this auto solver, thinking about what objective functions I wanted to give it and how that would shape the kinds of things that it did. And I noticed that it was feeding back into kind of my work as a game designer and my thinking about how to make games. And I feel like it's been that way kind of my whole career, like working on systems like Angelina and Puck. They have influenced how I think about making games. And I think that's actually why I like this job so much, because it gives me a chance to think about games from all these different perspectives. And when I talk to other game developers, I feel that I'm coming at it from a different perspective as well. And so I think Pixie might be sort of a way to encourage people to begin thinking about their own games in this way and to come to game design with the mindset of an AI researcher maybe or a generative systems researcher. And so I think for me, this secret third thing that we can do, or at least I feel like I want to do as a researcher, is to actually create just new skills or new disciplines that people can pick up. And maybe one of the things that we want to do as generative systems researchers is not produce things for game designers to use, but to turn game designers into generative systems researchers, or to AI researchers, and to get them to explore games themselves through an AI lens or from an AI standpoint. Um, and I don't know exactly how hard that's going to be, or the best way forward to doing it, but I think Pixie might be. Sorry, I've clicked on something in Zoom and I've now. I think Pixie might be one way towards doing that. I am literally 2 slides from the end, and I might have to ask you to close my. Oh, I'm drawing on the slide now. Okay. The problem is that I've lost my mouse cursor. Wait. I figured. There we go. Um, and so yeah, I don't know exactly how that's going to how that might happen, but we kind of do have a history of doing this, right? Generative systems is a field that has come out of nowhere. It has a long history, and it has a long history even in video games, and it's had a lot of different people kind of developing it, bringing skills to it, becoming generative systems experts, many of which are in our community. And maybe there's something that we can kind of grow there and develop. And give more people the kinds of skills that we use when we're writing our papers and building our research systems. Because the more I combine these two things, the more fun I find it and the more interesting I find it. So I'm hoping Pixie can be the start of that for my work. We'll see how successful that is. Before I wrap up, I'm very close to time. I've got a book coming out next year. It's called Next Level. It will be in normal bookstores about procedural generation and games. I'll tell you more about that closer to the time. And I've got lots of wonderful students and colleagues who are about to become ex-students in some cases, looking for postdocs. So look up their work and hire them as well. Thanks so much for listening. I will stop sharing.
Yeah.
There we go.
Okay, so we have like two questions from the audience. So the first one is in Pixie, how do you handle the fact that some mechanics might also have a visual component to them? Or is this not allowed? Like, for example, the flashing disk in disk room. So
Yeah, so there's definitely some things. I mean, if the developer was sort of had enough kind of nous about them, they could implement something like this, right? So if you wanted a visual component, you could write the AI player so that it reacts to whenever that visual stimulus happens. You'd have to kind of approximate in the same way that we approximated worst reaction time. I didn't mention this by having them decide on an action and then wait 5 frames to make the action. So, you could have things like visual distractions, or if things are invisible, you don't allow them to react to it, that kind of thing. It depends on the auto player, I guess. Yeah.
okay, another one. As I understand in Pixie, when you generate a new disks in the room, Are these meant to represent entirely new enemies, or are they more about introducing new behaviors for existing enemies? I'm wondering how this approach relates to testing player mechanics, since traditionally adding enemies help explore and challenge those mechanics. Does Pixie take a different perspective on this?
So if I think I understand the question correctly, you're kind of asking about the difference between adding sort of an extra bit of code to an existing enemy, for example, like allowing Goombas to fire fireballs, versus like creating an entirely new object.
I
So
think so.
Pixie can do both of these things. Basically, Pixie will do kind of whatever you ask it to, in the sense that if you point a bit of code at something and you tell Pixie, I want you to insert some code here, it will do it. And then you tell it what that code should end up having an effect in the game, and it will do that as well. The instantiating new objects became a little bit tricky. So this was the last thing I added to Pixie, actually. So Pixie can create new objects if it's given the template for them. Um, we kind of fudge creating, if you're familiar with Unity, creating a new prefab. But Pixie can essentially create templates for prefabs and then instantiate them. So if we want, Pixie can create entirely new objects. But if you wanted to just, which is what we did in Discrim, take like kind of a blank object and say, I want you to make this more interesting. I want you to make it do something. We can do that as well. And we can do like, the stuff we were doing in Mechanic Minor. We can say like when the player presses a button, like something will happen, and you decide what that something is. A lot of it, like the complexity of the task being given, will affect kind of how much of an autoplayer you need and how good the kind of results you can expect from it. So I'm definitely not trying to suggest that it's like sort of like a tool that solves everyone's problems. But it's definitely it's got a range of things it can do, and if you go down one end of the range, it's quite easy to get things out that are kind of fun and interesting.
Thank you. So one last question, then we need to move for the time. Is there some web page we can watch to know when the book comes out?
Yes. My my Blue Sky is a good one, because I will definitely be yelling about it on there. Possibilityspace.org, which is my homepage. I'm sure I will post about it there as well. It's probably not going to come out until early next year, and I will be yelling about it. I will probably come to your house and yell at you about it at some point, so you don't need to worry.